Hey, fourth hour, how's it going? Today, since I'm gone, I wanted to still be able to provide you some chemistry content from me. Okay, I'm going to work through 3 questions for you on your Chapter 2 problem set. These are 3 questions that I worked through yesterday with fifth hour, and according to fifth hour, they thought it was helpful. And this is kind of me trying to respond to some of the feedback that I got. A lot of people were requesting more examples to be worked through in class. And so since I'm not in class, I wanted to give you a video to watch today that still kind of hopefully helps you through this. This might be a long video. There are 3 questions. And it takes a little bit of time to explain each question, but you guys have the benefit that fifth hour didn't, in that you can pause the video and go back and rewatch and rewind and slow down if you need to. Obviously, you won't be able to ask me questions right now, but you can pause the video and watch it again if you need to. Okay, so the first question that we're going to do is number 9. And number 9 is a 2-part question, part A and part B. Part A, and both parts of question number 9 are relating to the periodic table and its arrangement. Okay, so we need to be familiar with how the periodic table is arranged. And if you're unfamiliar with that right now, 65 through 69, those pages in your textbook, and this key concept video, which hopefully is something that you've already watched. Those resources, at least within Mastering Chemistry, will be able to help you to build that content knowledge before you answer this question in your homework. But hopefully watching this video helps you just the same. Okay. So part A is asking, which of the following pairs of elements do you expect to be most similar? And we have answer options of, and I'm going to make sure that I'm on a good color here. And yeah, that's good. Okay. We have answer options of lithium and sodium. We have argon and bromine. We have germanium and arsenic, nitrogen and oxygen, and titanium and gallium. Okay, so one thing that we need to kind of think about is how this periodic table is arranged. Okay, and the up and down columns are referred to as groups or families. Okay, the rows side to side are referred to as periods. Okay, so from lithium over to neon, that would be 1 period. From hydrogen down to francium, that would be 1 group. Okay, the periodic table is arranged in the manner and such that groups have similar properties and similar characteristics. And so we are looking for 2 elements that are within the same group. Right here, lithium and sodium, boom, there we go. Okay, we can automatically kind of rule out things that are not close to each other, like this titanium and gallium option. Those are going to be way far apart on the periodic table. Lots and lots of differences in terms of their properties and similarities. Okay, bromine and argon, yeah, they're close, but they're not in the same family and they're not in the same period. Okay, so not going to be very similar. And then we need to look at, are they side to side or are they on top to bottom? When they're on top to bottom, now we're talking about groups, and those groups share similarities. Periods don't necessarily. Nitrogen and oxygen react very differently from one another. Same with germanium and arsenic. Okay, so yes, they're close to each other, they're right next to each other, but they react very differently. These elements here in this group, this would be group number 1, these elements have the same number of valence electrons as each other. Okay, and it's those valence electrons that determine its reactivity and establish a lot of the characteristics and properties of each element. And so when we have the same number of valence electrons, that's when we see similarities. Okay, so then we can come over here and confidently say lithium and sodium, submit, boom. Part B. Part B is a little bit different. It's a sorting question, and again, this is mainly conceptual. Okay, I'm going to try and make this a little bit bigger just so we can see some stuff. But this is basically explaining, so part B is asking you to explain why you chose lithium and sodium and none of the others. Okay, and you're going to be using these vocab terms: main group metal, transition metal, group, period, non-metal, and metalloid. Okay, I'm going to come back over here and hopefully zoom out a smidge so we can see the whole periodic table. I'm going to erase some of my scribbles. Okay, I've left on there groups and periods for our reference. This section here in the middle is referred to as the transition metals. Okay. These over here plus all of these over here, these are the main group metals. Okay. Metalloids are the stair step right here in the middle. I'll erase that because I just covered it all up. But the stair step right here in the middle, that is the metalloids. And the non-metals are right up here. And I should adjust this main group metals. That should be more like this. Okay, we're going to cut out that stair step. And then these right here are the non-metals. Those are your gases and other solids that, and some liquids that are not metallic. Okay, so that's knowing this about the periodic table should help us answer these questions. Okay, lithium and sodium are the most similar because they are both blank elements located in the same blank and therefore have similar properties. I think it's going to be easier to answer the second one on this one. They're both located in the same group or period. Definitely group, because lithium and sodium are here on top of each other. Okay, they are both blank elements, and our options: main group metals, transition metals, non-metals, or metalloids. They're not transition metals because they're not here in the middle. They are not metalloids because they're not along the stair step. They're not non-metals because non-metals are over here by oxygen and fluorine. And so that leaves us with main group metal. And let's fill that in. Okay, then we can move on. Nitrogen and oxygen are not the most similar because they are both blank elements and are located in a different blank. Okay, so nitrogen and oxygen, not the most similar because although they are both blank elements, let's see, not metals, not metals, not metalloids, let's go with non-metals. Drag that over. And each are located in a different, let's see, nitrogen and oxygen are here. They're in the same period. They're going to be in a different group. And we can drag that here. Let's keep moving. Titanium and gallium are not the most similar because titanium is a blank and gallium is a blank. Okay, titanium is here, gallium is here. Titanium is going to be a transition metal because it's here in the middle. It's a transition metal. There we go. And gallium is a what type? A main group metal. And we can put that here. It's not a metalloid. It's close, but it's not quite a metalloid. It's not a nonmetal. It's not a transition metal. It's a main group metal. Germanium and arsenic are not the most similar because although they are both blank elements, they are each located in a different blank. So we're talking germanium and arsenic right here. Let me erase this so that we can see this. Germanium and arsenic are both not transition metals. They are metalloids. And I won't be able to get to there we go. They're both metalloids. But they are each located in a different group, again, because they are side by side and not top to bottom. Okay? Argon and bromine would not be the most similar because, although they are both blank elements, they are each located in a different blank. And now we've got argon and bromine right here. They both fall under the category of nonmetals. So we can drag nonmetal here. They are each located in a different, I feel like they're both in a different group and period. So really, either one of these should be the correct answer because they're not in the same row and they're not in the same column. Okay, so they are both in a different group and a different period. And then we can hit submit. And tells me it's completed. I know that that's the right answers though. All right. So there's question number 9. It's really conceptual. Okay. Basically, you're understanding the arrangement of the periodic table and the different sections within, and being able to kind of identify and pull out bits and pieces of information based on the periodic table and its arrangement. Okay. That's question number 9. We are going to go to question number 12 next. Let's get there. 10, 11, and 12. And I'm going to, oh, how did I do this? I could erase my work earlier. No, it's not that. Here it is, restart work. That way I get a blank question. Okay, so let's zoom out here. We're gonna make this a little bit bigger over here, a little bit smaller over there. Okay, we're gonna go to number 12. And again, it tells you up here on number 12 that if you need some textbook help, these are your pages. Here's a link to a video you can watch to help you work through this question if you need extra explanation after I'm done. Okay? But what the question is telling us is it tells us to use the mass spectrum of rubidium to determine the atomic mass of rubidium. Okay, so basically what happens here is that a sample of rubidium gets thrown into a mass spectrometer. You don't need to know what a mass spectrometer is. This is the results. Okay, we have the mass of 85 results in an intensity peak of 100%. The mass of 87 results in an intensity peak of something less than 50. 50 is about right there. We'll call it 40%. Okay? So rubidium 85 gives us a peak of 100%. Rubidium 87 gives us 40%. Okay? What we need to do is find a total intensity for both isotopes. Okay? Because rubidium 85 and 87 are different isotopes. But we need to find a total. So we just add them together and we're going to get 140%. It's okay that this number right here is more than 100%. We're not worried about that right now. Okay? So that's my total. Now I need to find the percentage of each isotope out of the total. Okay, so I'm going to take 100% divided by the total, and then I'm going to take 40% divided by the total. And that's going to give me my percentages for rubidium 85